All right, so welcome everybody. This is Introduction to Internationalization and Unicode Internationalization Technologies. Don't ask me to say that too often. So let's get started here. We'll do a little overview to kind of explain what we're going to be doing in this tutorial. So first, introductions. This is me looking very stern with my glasses on. So in general, I am a person who loves, thinks about, and has my mind blown by internationalization and localization all the time. I've worked on the technical side mostly as an engineer, an architect, and an engineering manager. I worked at Adobe, Domo, and Spotify most recently. I forgot to put Wikimedia up there too. I did Wikimedia too. I am a classically trained sinologist. 10 points if you know what that means. Does anybody know? China specialist. Okay. I used to focus on early Chinese language and culture, particularly the pre-Qin era. I taught classical Chinese at Stanford, which was a long time ago, as a researcher and teaching fellow in the departments of East Asian languages and religious studies. I am now working as a consultant and a developer. I have my own little company. I advise people on how to internationalize and localize their software. As Toril mentioned, I am a member of the Unicode Community Engagement Team, a volunteer member, and I am recently appointed as the co-chair of the W3C's I18N working group. So that's me. Let's do some introductions the other way. How many people, I asked this before, but how many people are students? Okay, how many people are from MISS? Okay, well, we're glad to have you all here. That's a good read of the room because if I talk about this tutorial a little bit, I want to emphasize that this is a very introductory tutorial. It assumes no Unicode knowledge whatsoever, and it's designed to help you learn the basics of developing international software and understand the Unicode internationalization technologies that make it possible. So the audience is people who are completely new to internationalization. The purpose is to prepare you for the tutorials that will come later in this track, which are on ICU and ICU for X. It's going to be very broad, very high level, and we're going to focus on how everything fits together rather than diving deep into any particular subject. And the goal is to provide the kind of foundational knowledge you need to really succeed in the tutorials that are coming. And because of that, it's going to be mostly presentation and not lab work. There's just too much to cover and have it be extremely interactive. So the content of this tutorial, I'm going to focus on 4 topics, which I am defining in terms of 4 basic questions that kind of cover the fundamentals. What is internationalization? What is internationalization about? How does internationalization work? And what does internationalization involve? So really basic stuff. And each of those questions is going to be covered in a separate section of the tutorial. And the sections are organized so that the later sections build upon what's introduced in the earlier sections. The sections are internationalization concepts and relationships. That's going to really try to answer the question of what is internationalization and why is it important. Internationalization focus areas and concerns, which will look at what internationalization is actually about. A brief survey of Unicode internationalization technologies. That's going to be the part about how does internationalization work. And then the internationalization life cycle, which will focus on what does internationalization actually involve. Okay, structure. Each section starts with a summary and a list of objectives, and each section ends with a takeaway list and links to resources for learning more about what was covered in that section. Materials, a PDF of the slide deck will be available on the conference website a few weeks after the workshop is done. And the website will also have a link to the recording on the Unicode YouTube channel. So what that means is, unlike some localization conferences I've been to, there is no need to take pictures of the slides. You will get a copy of them later. Second, the slides are really wordy and boring. I've intended them to be an artifact that can be used as a reference later, rather than something that you're going to have to read all of it during the tutorial. And most of the important content in the tutorial is actually going to be verbal. And so it's better to focus on listening to what is said as opposed to looking and trying to capture everything that's written on the slides. Logistics. We have a lot of ground to cover and only really 90 minutes in which to do it. And that is not leaving time for questions, so we got to do it a little bit less than that. And so that requires we have some ground rules. The first one is that questions and comments are welcome during the presentation, but they have to be kept short because we have a lot to cover. There will be a dedicated Q&A session at the end of the tutorial, so when in doubt, wait. And let's keep the discussion professional, be nice, and do not monopolize the available time. Any questions before we really get into the meat of it? All right. Let's start with internationalization concepts and relationships, which looks at what is internationalization. So I was trained as a philosopher, so I spend a lot of time thinking about what concepts mean and how they relate to the terminology that we use to talk about them. So what this section is going to do is introduce the basic concepts and relationships that define what internationalization is and why it matters. And it's going to do that by analyzing the terms we use to talk about internationalization in English. Doing this serves several purposes, but I want to highlight three. One, it forces me to be explicit about how I'm going to use certain terms, which should avoid misunderstanding. Two, it allows us to develop some kind of shared understanding of what the terms mean, which will facilitate communication. And then three, most importantly, it provides a way of understanding the concepts and relationships to which the terms refer by using language as a fish trap. So what do I mean by that? This, I swear, will be the only early Chinese thing I sneak in. And this is a quote from Zhuangzi. Does anybody know Zhuangzi? Okay, he's a Taoist philosopher from early China. And he says, a fish trap exists for the sake of fish. Once you've caught the fish, you can forget about the trap. A rabbit snare exists for the sake of rabbits. Once you've caught a rabbit, you can forget about the snare. Words exist for a sake of meaning, and once you've caught the meaning, you can forget about the words. Or where can I find a person who has forgotten words so that I can have a word with them? So the idea here is that we're going to spend a lot of time defining terms, but the terms themselves are not as important as the concepts we're using those terms to understand. Okay? So, objectives, we're going to start by describing the etymology of the English term nation and explain why the development of the term is significant. We're going to clarify the meaning and difference between local, national, and international and explain how the concepts behind the terms are related to each other. Then we're going to distinguish between international software, software internationalization, and internationalization technologies and explain how they all fit together. Finally, we're going to look at the context in which internationalization exists by showing how internationalization relates to terms you might be more familiar with, like localization, translation, and globalization. Okay, any questions? All right. So let's start by looking at the etymology of nation. The term nation actually comes from the Latin word natio, which means of common origin or birth. So it was originally more a kinship term, but over time, the meaning has expanded to include other groups of people who share a common origin. And depending on what kind of origin it is, you end up with different conceptions of what a nation is. Like if it's an ethnic origin, then you get something like a nationality. If it's a country or territorial origin, then you get a territorial nation. And if it's citizenship in a particular political system, you get what's called a nation state. But what's important about the concept of a nation is that the members of a nation often share a common language or set of languages, and they share important cultural traditions and social systems. Okay? So let's move on to the distinction between local, national, and international. Local we're going to use it to mean that it's associated and involving a user's immediate context. So you can think of localization has to do with local. National is associated or involving the people of a whole nation. And national is greater than local, which is greater than personal in terms of inclusivity and specificity. National is less than international, but greater than local. And finally, international, and this is the kind of standard dictionary definition, is associated with two or more nations, which means it's not a scalar distinction, it's a binary distinction in that something is either international or it's not. As soon as you have two or more nations involved, you're already in the international realm. So, how does all this apply to software? Well, you can think of international software as software that works internationally. It's software that works for an international context. And because it works in that manner, it works internationally and is somewhat generic and abstract, it has the ability to adapt to meet the needs and expectations of users in any national or local context. So the specific international requirements for an application are always going to be unique. It's going to depend on what kind of application it is, what industry it's involved in, what kind of markets it's directed toward. But there are certain features that are kind of common to an international piece of software that I've listed here. It generally complies with all the international standards, so it can operate internationally like that. It's not specific or biased toward a particular context. It has this kind of contextual awareness where it can tell, well, this is what context I'm dealing with now, and then it has some kind of decision logic that says, oh, well, this is what I should do in order to respond to the needs of that context. It typically has support for multiple languages, scripts, regions, and cultures. And it can deliver different localized experiences to different audiences based on the user's preferences. And finally, the ultimate goal of internationalization is to be able to produce an experience where the application interacts with users in a way that is accessible and feels natural to them. Okay? So that brings us to internationalization, which now that we've defined international software, we can define internationalization as simply a set of architectural principles and engineering practices designed to produce international software. And that means designing and supporting software that works internationally and supports adaptation. One way to think about it is international software is the product, and internationalization is the process that produces that product. In order to be effective, as we'll see, internationalization has to be embedded in the software development life cycle. It requires widespread involvement and support throughout the development organization. It's not just an engineering thing. And it includes both systemic and local feature development. That means architectural systems that go throughout an entire application that individual features tap into, and then the actual development of the features themselves to support internationalization. And then finally, it intersects with localization and translation and globalization. So, internationalization technologies. An internationalization technology is a technology you use to do internationalization. A tool you use to produce international software. And these technologies have been developed centrally and in an open source manner so that they encapsulate internationalization principles, design patterns, and best practices, and they're done open source through Unicode so they're available to everyone. what I mean by technologies and why I'm not just calling these software is because it includes standards, properties and algorithms, structured locale data, libraries, packages that you can use in the development of software, exposure of those libraries and packages through programming language APIs and platform SDKs. So this brings us to localization. Localization is the actual process of adapting a software product to meet the needs and expectations of a particular local context. And if we think about how internationalization relates to localization, internationalization enables localization to scale by making it possible to non-destructively adapt a piece of software for multiple local markets. You can localize without internationalizing, but it's kind of like a one-shot deal, and it breaks the link between the existing code base and the particular localized version. So what internationalization does in relationship to localization is make it so you maintain that link between the code base and the specific adaptation, and you don't destroy or make a copy that is completely separate from ongoing development of the software. Localization can involve many aspects in relation to software. You have the interface localization, you have the application localization, which may involve messages coming from servers and up in the cloud, as well as the architecture of the actual client application itself. And then importantly, there's content localization, where you may have localization that is available in many different languages, and you have to figure out which kind of content you want to surface to which users. So translation, this is something that everybody from MIST has a lot of experience with. I'm going to define it very simply as the process of transferring information from one language to another. Now, by information, that encompasses things like meaning and intent and all those good things they teach you. In terms of the relationship, internationalization can have a positive or a negative relationship on translation. On the one hand, it expands the possibilities for accuracy in translation through things like pluralization support, grammatical agreement patterns, things like that. But it can also have a negative impact in that it can make the translation process more complicated. Translators need to know how to deal with those patterns, or you need to have some kind of system that removes that complexity and just surfaces the actual text to translators. And finally, translation applies a set of, localization applies a set of translated resources to an internationalized application. So the translators produce resources, and then as part of the localization process, those translated resources are combined with an internationalized code base to produce a localized experience. Globalization. You can think of globalization in the sense we'll be using it here as equivalent to international expansion. And that is from fewer contexts to more contexts within some kind of limited, well-defined whole. So that's really apparent in the concept of globalization itself. The globe defines all the contexts that are available, whereas when you globalize an application, you go from maybe supporting 4 contexts or languages to 10. So you're not only increasing the amount of markets or locales that you support, you're increasing the share of the total that you address. Globalization usually depends on factors that go way beyond the actual software development process. There's marketing, there's sales, there's customer support. And then the more you globalize, the more markets you introduce, the more features you extend localization to, the more complex the internationalization process actually becomes. Because you have to now support right to left languages, or you have to support multi-byte languages, whereas if you're originally just operating in Europe, then you maybe only have to support the Latin script. Okay, so quick takeaways. That was a quick run through. The concept of a nation is complex, and that makes it really hard to say what are different national characteristics. Are you talking about an ethnicity? Are you talking about a country? Are you talking about a political entity? Local, national, and international represent different points along a spectrum of specificity and inclusivity. And they range from more specific to less specific. International software is software that works in an international context and works internationally so that it can be adapted to multiple specific contexts. Internationalization is the process of developing international software, and it involves relying on internationalization technologies, most of which, as you will see, are developed by Unicode. Internationalization enables localization to scale by making it non-destructive and supporting multiple things at the same time. And then it affects the complexity and accuracy of translation, which has an impact on localization quality. And finally, it facilitates globalization by making it easier to extend localization to more features and services and more languages and markets. Any questions at this point? Clear as mud? Great. Okay, learn more. The definitions of internationalization related terms in these online sources should be surveyed and compared to those created here. There is no one definition of internationalization really, and they kind of all fall in the same general range, but there are lots of specific internationalization definitions that are out there. I would start with the W3C I18N working groups about internationalization page, which is linked there. And we have an internationalization glossary, which basically provides normative definitions of a lot of different terms, like this is what a language is, this is what a locale is, this is what a script is. A similar but less accessible terminology can be found in RFC 3536 from the Internet Engineering Task Force, or IETF. You can take a look at that too. And then there's some good but very brief definitions of international and localization that are provided at the beginning of the Unicode Technical Quick Start Guide. So all of these are live links, so when you have the PDF, you can click on them and do further research. Okay. Let me do a time check real quick. Cool. Let's talk about the focus areas and concerns. This is really looking at the question of what internationalization is about and what specific problems it's trying to solve. So that is a lot of text. Basically, to summarize, what we're going to do is we're going to start by looking at IETF BCP 47 language tags and the derived Unicode locale identifiers. Man, I cannot speak today. And then we're going to take the parts of those tags and identifiers, and we're going to use them to identify the main subject areas that internationalization deals with. And then we're going to take each of those subject areas and break it down into specific problems and show how developing software in an international environment makes the problems associated with things like language and writing more complex. And then finally, we're going to take a look at the variety that exists out there in the world and the different kinds of complexity that you actually have to deal with. Okay, so start by introducing the concept of a locale and analyze its definition. Discuss the composition and syntax of IETF language tags and Unicode locale identifiers. Explore the focus areas, describe what each is about and the main problems associated with it, and then describe the international diversity that exists within each focus area and show how that makes things more complicated. Pretty simple. Okay, locales. I should mention that for this section, rather than trying to provide my own definitions or anything like that, I've just quoted from actual documents, and that's what you're going to see on the screen. And I'm just going to kind of summarize what they said. So the first issue we have to look at is, what is a locale? I think a lot of people associate a locale with a place or with a language. But the way it's defined in BCP 47 and the locale data markup language is as an identifier that refers to a set of user preferences that tend to be shared across significant swaths of the world. I love the word swaths. So traditionally, that is used to point to a collection of data, which is used for doing things like sorting, providing translated names for things like places and languages, defining the boundaries that exist in scripts between words, sentences, and characters, doing text transformations, including transliteration, and a lot of other things. If you want to read more about that, you can go to this link right here, which is TR35, which is the LDML specification, and the particular section is what is a locale. I think that was written by Mark Davis and Addison Phillips, who wrote pretty much everything having to do with internationalization. So a locale is an identifier, and the structure and syntax for constructing these ideas, these identifiers, is defined in a specification from the Internet Engineering Task Force called Best Common Practice 47. And it says a language tag is composed of a sequence of one or more subtags, each of which refines or narrows the range of a language identified by the overall tag. Subtags, in turn, are a sequence of alphanumeric characters, letters and digits, distinguished and separated from other subtags in a tag by a hyphen. And they actually show you the actual Unicode code point for a hyphen there. That's what that last part means. And you can find that in, there are actually two RFCs that make up BCP 47. This is the second one, which is about the definition of language tags, and the other one looks at the actual matching of language tags between a user's preferences and the languages that you may offer. So here are some examples of language tags. You can have just a general language all by itself, like ZH is going to give you Chinese. You can have an extended language tag like ZH-CMN, which refers to Chinese Mandarin. You can have a script tag that will tell you Chinese in the simplified script. You can skip the script tag and go directly to the country and have Chinese as spoken and used in mainland China. You can do a fully specified tag like ZH-Han-SCN, which is simplified Chinese from China. And you can do extended languages with a region and a language tag like ZH via HK, which is Cantonese Chinese from Hong Kong. The last part of a tag is something that's called a variant, which is more an orthographic tradition or some other kind of tradition that is even more specific than a particular language. So like DECH 1901 is Swiss German using the 1901 orthography or spellings, and CAES Valencia is Catalan as spoken in Spain and in particular in the region of Valencia. And then finally, any tag can have a private use area, which is designated by this singleton character here, the X. And then there are key and value relationships that you can use to add your own customization to a language tag. Okay? So one of the things about BCP 47 language tags is they can be extended. And this mechanism that they use for extending language tags is similar to the private use mechanism in that you define a singleton, And then you have key value relationships that show specific things in your system or software. So the Unicode Consortium has registered with the International Standards Association and maintains as the authority for 2 BCP language tags. The extension U for Unicode Locale Extension, which is what we're going to focus on, and then the extension T for transformed content, which means like this is Chinese translated from English, or this is Chinese in pinyin that was translated from simplified Chinese characters. That's what the T would be used for. And BCP 47 extension data defines the complete list of valid subtags. You have a link there. And here are some examples of some of the Unicode extensions that are in use today. You can specify the calendar algorithm, the currency type, currency formatting type, dictionary break script exclusions, emoji presentation style, the first day of week that needs to be used, and the hour cycle that is used in a particular country, the measurement system you want to use, and regional subdivisions within a region. Okay, so why does any of that matter? Well, it matters because the subtags and syntax of IETF language tags show that there are 4 main aspects to a user's localization preferences as they're defined today: language, script, region, and cultural tradition. And the extensions defined for Unicode locale identifiers show that a user's localization preferences may extend to a preference for using specific linguistic, scriptographic, regional, or cultural systems. Okay, and what are the implications of that? Well, if we look at the 4 main aspects of a user's localization preferences and examine what each aspect's core features and concerns are, then we can begin to understand what internationalization in general is about. And if we look at the diversity that exists within each of these aspects and what is required to support this diversity in a technological setting, we can start to understand why internationalization is necessary and what it's meant to accomplish. So let's do that. So let's start with languages. Languages are commonly defined as a conventional system of communication used by the members of a society or nation. Language consists of 2 main elements: a vocabulary and a grammar. A vocabulary is a system of words, and a grammar is a system of rules for using those words. The study of language is called linguistics, and it encompasses several different subfields like semiotics and lexicology, the study of signs and words, phonology and orthography, the study of how you combine sounds or letters in a written script, morphology and syntax, the grammatical forms and functions of words, semantics and pragmatics, what they mean and what you're trying to accomplish when you say something, taxonomy and phylogeny, which is how you classify languages and how they're genetically related to each other. And then finally, translation and interpretation, the translation of information between languages, whether spoken or written. So let's look at the diversity of languages. According to Ethnologue, there are 7,159 languages currently in use in the world today, and many more historical and extinct languages. Current languages can be categorized into 142 different language families. 81.9% of languages are institutional, which means they're formally recognized for use in some field or something. 16.9% have a stable community of speakers, and so they're not in danger in any way. But there are 1.2% of languages that are endangered and at risk of becoming extinct. Languages can vary in terms of vocabulary, pronunciation, orthography, and grammar, and languages tend to vary according to origin, region, social rank, and individual preferences. Some languages are highly inflected and change the form of words in order to signify grammatical relationships, while others are completely uninflected, like Chinese, which doesn't change the form of words, but just moves them around differently in the sentence and uses particles and things like that to indicate grammatical relationships. So how do you support all that diversity in a technological context? Well, historically, computer systems are text-based, but voice-based interfaces are becoming increasingly common. And certain features apply to both speech and writing and must be supported by both types of interfaces. And this introduces complexity when composing messages with dynamic content. And what I mean by that is when you have like a variable or something that you want to put into a sentence, you need to adjust the pluralization, the gender agreement, and things like that. And that is a major internationalization concern. So pluralization, we generally work with these categories. There's 0, 1, 2, few, many, and other. And like English and Chinese have just one and other, but Arabic has 9 different pluralization forms. Tense, which refers to when something happened, past, present, or future. Aspect, which has to do with whether it's ongoing, it's been completed, or it has started and is ongoing. Gender, male, female, or neutral terms. And then person, whether it's first, second, or third person. So it's much easier to talk about language in terms of scripts because talking about language in the abstract as being neither speech or writing is a little bit difficult. But when you get to scripts, you can say that script is a set of grammatical symbols, which are called graphemes, that can be used to write one or more languages. A single script may be used to write multiple languages. Graphemes are also called characters, and so a script can also be called a character set. Scripts are the graphical elements that make up one part of a writing system. The other part consists of a set of rules and orthography that governs how scripts are used to represent languages. The study of script is called scriptology or scriptography and has given rise to a bunch of subfields like graphology, written characters, paleography, ancient scripts, epigraphy, specifically scripts in inscriptions, which I used to spend a lot of time with, calligraphy, the study and practice of handwriting, and typography, the style and appearance of printed text. So, diversity. Recent estimates suggest that there are around 293 known writing systems, of which 156 are currently in use. The remaining 137 writing systems are historical. Some writing systems like Japanese use multiple scripts, hiragana, katakana, and the Han characters, while some scripts like Latin are used to write multiple languages. Scripts can be alphabetic, syllabic, logographic, or featural like Korean. Some traditional scripts like Mongolian are written vertically in columns, while most modern scripts are written horizontally in rows. Most scripts are written from left to right, but there is an important subset of scripts that are written from right to left. And when right to left and left to right scripts are combined and appear in the same piece of text, the result is called bidirectional text. So technology, again, a lot of text. Computer systems only store text in terms of bits and bytes. To represent text in software, you have to take a character and encode it into bytes of some form. And you have to arrange those in a linear sequence of bytes, which are generally referred to as strings. To display text, these encodings have to be mapped to a font, which has glyphs for each character. And the fonts include data tables that explain how to combine and order characters in order to produce the desired result. In some writing systems, multiple characters can be combined to make what's called a ligature or grapheme cluster. Character and ligature boundaries are tracked by font rendering and shaping engines in order to allow for features like cursor positioning and text selection. And the boundaries are also used for sentence, word, and grapheme line breaking. So how things wrap, where it breaks in a sentence, how you justify things. Then variable fonts include different weights and styles of glyphs that can be used for decoration and emphasis. And text direction is controlled by an algorithm developed by Unicode that uses character properties associated with individual characters and directional markers and isolates to determine the proper sequence and order of characters. Make sense? That's a lot. Okay, so that's the technology, and that brings us to regions. A region is a territorial unit that may or may not be associated with specific nationalities or a particular nation state. Regional localization preferences take the forms of variations in language, variations in script, and variations in cultural systems and traditions. If you look at the locales defined for the Common Locale Data Repository, which we will get to in the next section, they include 305 regional variants. That means there's a main language, and based on the region, you can define 305 different languages that are specific to the region. And one way to think of those is just dialects, right? So the following are some examples of localization preferences that tend to vary according to region. You have toponyms, place names, addresses and phone numbers, time zones and metazones, currencies and currency formats, date, time, and date time formats, and calendar number and measurement systems. So, diversity. Many nations have multiple nationalities, and many regions have multiple nationalities in them, and some nationalities extend across multiple regions. Regions have different forms of administrative divisions, and these divisions often correspond to sub-regions or territorial units like states or provinces. The names used to refer to particular places are different in different regions, and different regions may have different address and phone number formats. Addresses in computer systems are generally geocoded into coordinates, and regional boundaries are used to define different time zone and metazones. Metazones are like Pacific time as opposed to an offset from universal coordinated time, like universal coordinated time +7. Different countries may use different monetary, calendrical numbering and measurement systems, and even when the same systems are used, the formats used to write currency amounts, dates, times, numbers, and units often are different. And the standard example is where you put the month and the day in the UK as opposed to the US, which is often very confusing. So that specificity is very important when you're doing localization. And so digital technologies need a way to specify regions and languages that are both more specific and less specific than a country. And that's what some of the extensions like the sub-region extension that we saw earlier for. And then CLDR also defines what are called macro regions like Europe, Asia, Africa, And also defines some weird political entities like the UN and EU countries. So it's again that ambiguity surrounding the concept of what makes a nation and what you're actually going to consider to be the characteristics. So in general, place names, like I said before, they are geocoded in computer systems, and the boundaries become vector polygon shapes. And the process of geocoding place names and addresses becomes much more complex by the fact that there are different names for places and different views about what the boundaries of a particular territorial unit are. Formatting different types of primitive values. Primitive values are things like a number, a Boolean, a date. Usually involves collecting the right elements and then defining the right patterns for those elements. And those can actually be patterns or rule-based. And then you have an algorithm that produces what are called value strings through token substitution. So you basically have a name per month, you have a pattern for how a date should come out, and you stick the name per month in the pattern according to a specific rule. Parsing does the opposite. It converts value strings into other value types, and the number of languages, units, regions, and format styles that exist can make managing all the permutations associated with different number and date formats really hard to manage. And there's actually a whole technical committee in Unicode that's pretty much all they do. Okay, last one, culture. Culture is a hard one to define, but it's often defined as the shared way of life of a group of people. And it's both an aggregate of the individual characteristics of the people in the group and serves as something that actually defines their identity and how they think about themselves. A tradition is a system that a group of people have developed over time in order to make their way of life easier, better, something like that. And traditions usually take the form in the present of shared beliefs, values, institutions, or practices. And they can be found across the spectrum of social and political life. So cultural traditions that are most of interest in terms of internationalization include onomastic systems. There's a word that you probably have not heard before. Personal and place names, proper names in general. Numbering systems, what digits, numbers, values, and math look like in a particular language or region. Calendrical system, the eras, years, months, days, and days of the week that exist, and how you convert between, say, a lunisolar calendar and a tabular Islamic calendar. Timekeeping system, which involves hour cycles, day periods, AM, PM. Some people use a 24-hour clock, some people use a 12-hour clock. And measurement systems, which define both a general system and then names for individual measures of volume, length, weight, etc. So today, a lot of these systems that we use are actually shared across traditions. Most countries and regions use the Gregorian calendar, for example. But there are some things that are still diverse, like your kinship system and how you think about familial relationships can have influence on the names you use to refer to people. For example, in Arabic, you might have a personal name that has like 5 components depending on who you're speaking to and when. Different peoples have different cultural traditions about how numbers should be grouped and what symbols should be used to represent the groupings and things like integers versus decimal numbers. Let's see, Gregorian calendar is the most commonly used today, but there's still many solar, lunisolar, seasonal, cyclic, and tabular calendars in use. And all of those are defined in CLDR. Some people use a 12-hour cycle, as I indicated before, with AM and PM day period indicators, while others use 23 or 24-hour clock to keep time. And while most countries use the metric system, there are still some holdouts like the United States, of course. Different languages have different names and abbreviations for different units within the metric system and different ways of displaying them as well. So, digital systems do not do well with ambiguity. And for this reasons, the creator of digital systems have created several steps to remove ambiguity from computer systems. They've created or adopted international standards like Unicode that assign universal values or identifiers, and they have specified and implemented culturally agnostic systems like the UTC or Universal Coordinated Time System that operate independently of any particular regional or cultural tradition. And what that does is it serves as an intermediary that makes it possible to convert between different systems. And that's usually how you handle things like time conversions, is usually converting between one time zone to UTC and then from UTC to another time zone in cases where you can't have a straightforward mathematical conversion that goes directly across, like with currency conversion, for example. That's a mathematical conversion. But to convert between some systems, you need an intermediary format. Okay, done with all that diversity talk. It's about creating support for different users' localization preferences. So this kind of solves the problem of the ambiguity of a nation in that you're really talking about the preferences of a user. 4 main aspects are language, script, region, and culture. Systems are the products of traditions. Language and writing are forms of systems. Developing software systems in an international environment requires supporting multiple sets of localization preferences. And digital systems can support multiple sets of localization preferences by adopting international standards and culturally agnostic systems. And this model allows an application to essentially be multilingual and multicultural, but in a way that you're only ever surfacing one particular language or culture to a user based on their linguistic, scriptographic, regional, and cultural preferences. So learning more. I would start by looking at the RFCs for composing and matching IETF language tags, BCP47. And then if you want to, you can go further and look at the discussion of how you match language tags that come in as someone's preference against the languages you offer. Then I would take a look at how locales are defined and extended from language tags to make Unicode locale identifiers in the LDML specification. And then finally, I would dig into the core LDML specification and look at the specifications for different linguistic and cultural traditions. Okay, all right. So we made it through the conceptual stuff. And now we can get to the actual technologies. So this is going to be very high level because there's a lot of complexity here. But in general, what we're going to do is survey the technologies that are produced by Unicode Consortium and others and then have been adopted by Unicode. And the purpose is to explain how internationalization works by looking at the technology that makes internationalization not only possible, but faster, easier, and more convenient. We want to provide a holistic view of the entire Unicode tech stack. And so the focus is going to be on explaining what each technology is, what it does, and how it contributes to the development of international software. So by the end of this, you should have a basic understanding of the Unicode tech stack and be ready to learn about how to apply this tech stack in your own software development projects. Okay, so we're going to introduce the Unicode Consortium, so everybody knows what that is. Provide an overview of the technologies that make up the stack and show how they fit together. We're going to describe each technology and highlight what it does and explain how it contributes to the overall goal, and then show how Unicode internationalization technologies are exposed through different programming APIs and platform SDKs. So, this is a quote from the About page on the Unicode website. Unicode Consortium, I cannot say that word, consortium, is basically a set of companies and organizations that get together to define standards and work through volunteers to develop code, tools, and libraries that ensure global language support. It's behind most of what you take for granted on screens today, not just with international diversity, but whatever language you speak, the fact that you can display it on your phone is due to Unicode. Let's see, it's embedded in every major operating system and used on more than 20 billion devices worldwide, and it may be the most widely deployed technology ever. So, this is the basics of the Unicode internationalization tech stack. This is also taken from the Unicode website. At the bottom, you have the actual Unicode standard. This is an encoding of nearly 150,000 characters covering the world's languages and emoji. Then on top of that, you have the Unicode character database, which contains properties that are associated with each of these characters that let you read them and know how to display them. Then on top of that, you have LDML and structured data, which is contained in the common locale data repository which is information about processing numbers, dates, calendars, that kind of thing. And then on top of that, you have the internationalization components for Unicode libraries, which use the characters, the properties, the algorithms, and the structured data to develop higher level algorithms that allow you to do things like format a date or format a number. So the Unicode standard is the universal character encoding for written characters and text. It defines a consistent way of encoding multilingual text that enables the exchange of text data internationally and creates the foundation for global software. Unicode is now a requirement for things like JavaScript, HTML, and communication protocols. And it's also used by all programming languages like C, C++, Java, and many others that have bindings to those libraries, so that basically any software you write now is going to be Unicode compliant. The standard works by specifying numeric values, which are called code points, and a name for each of its characters, and associates all kinds of character properties with them through the Unicode character database. And it's similar to other character standards from ASCII onward. ASCII is the one that lets you do basic Latin. It contains 1,114,112 code points, most of which are available for the encoding of characters. Most characters are encoded in the first 65,536 code points, also known as the basic multilingual plane. And with a capacity of over 1 million characters, it's more than enough to cover all characters ever created and ever will be created. So now you have this kind of like registry of all the characters that exist. But you actually have to get them, as we explained in the last section, encoded in a way that they can be processed by computer systems. And Unicode specifies 3 ways of doing that. They're called UTF-32, UTF-16, and UTF-32. UTF-32, 16, and 8. I'm sorry, I read that backwards. 32 is the simplest. Each Unicode code point is represented directly by a single 32-bit code unit. And so there's a one-to-one relationship between code points and code units. In UTF-16, non-surrogate code points, which are the most basic code points, are represented in a single 16-bit code unit, but more characters on the outside the basic multilingual plane are represented by surrogate characters, surrogate pairs, and so each character is represented by 2 16-bit code units. Got to make sure I get that right. And then finally, the most common that you see in like web development, because it allows for transparency and interoperability with ASCII byte standard encodings, is UTF-8, which is a variable width encoding, which preserves ASCII transparency by making use of 8-bit code units. And the way it works is you have what are called leading bits and trailing bits that explain that, whoa, this character is actually made up of 4 bytes, and this is the first byte, this is the second byte, this is the third byte, and this is the actual information that defines the character code points. Character properties. So Unicode doesn't just define how to identify particular characters. It collects all sorts of data about those characters, which may include things like its directionality, whether it's a combining character or just a regular independent character. And the importance of that information is that it can be read by, did I just lose my mind? It can be read by shaping engines and font rendering engines to determine how to, for example, make Arabic look seamless as opposed to broken into little units, so that it all flows together in a single word. Let's see. It has case mapping tables and other property tables, and those are all contained in something called the Unicode character database. Beyond this, there are character algorithms that have been defined through Unicode technical reports, which include annexes to the original Unicode standard that defines things like normalization. If you have a character like an A with an accent over the top of it, that can be either encoded either as a single character or as two characters that combined. And normalization is the process of going between those different representations. You have the line breaking algorithm, which tells you how to read the character properties to determine what the boundaries are between characters, words, and sentences so you can properly lay out text on a page according to a specific layout. You have the bidirectional text algorithm. And then finally, you have the collation algorithm, which is all about how you sort different characters based on their properties. Okay, just making sure I'm okay on time. So the great thing is that you can watch this talk, which is going on at the same time in the recording, and learn much more about all this stuff than I know. And I encourage you to do that. And then I encourage you to go to Adil's talk in the afternoon, which looks at bidirectional text display and UI mirroring. Then you have locale data markup language, which we've already talked about. It's an XML format for the communication of locale data. And what it does is, so you can always encode locale data the same way, and then you collect the data, and that allows you to have an equivalent experience across different programming languages because it's all using the same format to encode the data, and through the common locale data repository, actually using the same data and patterns and elements in order to produce the final formatted value strings. The CLDR, the Common Locale Data Repository, provides the key building blocks of software. It includes things like locale-specific patterns for formatting and parsing, translations of language, region, and script names, language and script information, what characters are included in a particular script, country information, really strange stuff like which are the official languages, which are not official languages, what are the percentages of speakers in a country that use a particular language. And then finally, it has things for checking the validity of Unicode strings. And then you take all that we've discussed so far, and you kind of bake it into something called the internationalization components for Unicode, which is what Ilongo will be talking about in the next tutorial. And it's a mature, widely used set of C, C++, and Java libraries for providing Unicode and globalization support for software applications. It's widely portable, and importantly, it gives the same results on all platforms between C, C++, and Java. So that means you can develop with Unicode technologies and the internationalization components for Unicode and have the same formatting, for example, produced on Android and iOS, even though those are Java and C-based. It's released under a very non-restrictive open source license. It's actually like one of the most liberal licenses I've ever seen. And it can be used in both commercial software and open source or free software. Some of the things that it does: code page conversion from Unicode to other encodings, collation, formatting of all those things listed there, time calculations between different calendars. It's got full Unicode support for characters, properties, and algorithms, regular expressions, bidirectional text, and text boundaries. I'm speeding up a little because I'm running out of time. So the latest development out of Unicode is something called ICU for X. It's an implementation of internationalization components for Unicode. That should be for Unicode, not of Unicode. And it's intended to be modular, performant, and flexible. It's written in Rust, and it provides a layer of APIs for all software that's very performant and memory efficient. And it enables internationalization capabilities on things like watches and devices because it's very fast, takes very little memory, it's very lightweight. And I I personally am not an expert on ICU for X, so I encourage you to go to the third tutorial in this section, which will be a quick start on using ICU for X. And when you're done, you can look at the quick start that's listed on the ICU for X website and take a look at the design principles that are also specified on the ICU for X website. Here's just a quick list of all the different companies and organizations that use ICU. Here are the programming languages that actually take ICU and expose its APIs through their APIs. So like I used to do for Adobe some terrible PHP applications that actually use ICU for C and expose it in the Intel API in PHP. And then finally, platform SDKs. ECMAScript has the Intel API. It's used in Windows, all Apple products, Android and all Google products, IBM products, Adobe Creative Suite, Apache and open source products. So it's used everywhere. So takeaways. They're developed by the Unicode Consortium, and they make it possible for international software to work. They include the standard, the character database, which has properties for the characters defined in the standards. Technical reports define those properties and algorithms for performing text-related functions. There's the common locale data repository, which collects locale data using something called the CLDR survey tool and publishes it using locale data markup language, which is an XML-based format, as we explained. And then there's the internationalization components for Unicode that uses the standard and consumes the data in CLR in order to support internationalization functions. Best way to learn more is to get involved with the Unicode Consortium, look through the standard and the technical reports, download the common locale data repository in LDL format, or view the data on GitHub in JSON format, which is much easier to consume. Take a look at the ICU user guide or work through the ICU for X quick start and learn how to leverage the ICU wrapper APIs for your platform SDK or programming language. And I've got links to the documentation for JavaScript, Xcode actually, not iOS, and Android. So that's that. We're to the final section. We're going to make it through. This is the internationalization lifecycle, which is about what does internationalization actually involve. So Unicode takes care of, I would say, 80% of the work that needs to be done to produce international software. But there is still that other 20%, which involves actually making an application international using the Unicode technologies. So this is about that other 20%. So what we're going to do is we're going to talk about something called the software development lifecycle, which is the common model that kind of presents an idealized view of what the development process is like for software. And then we're going to look at how internationalization is embedded in each stage, or each phase, they call them, in the software development lifecycle in order to make it effective. And then it's going to go through each phase and end with a discussion of what I call continuous internationalization and localization, and how to manage internationalization and localization expansion. And so by the end of the section, you should be all ready to understand what it takes to actually produce international software. So we'll define the 7 stages, step through each stage and highlight internationalization, continuous and internationalization and localization, and then talk about globalization through internationalization and localization expansion. So software development lifecycle is an idealized view of software development process. There are many different versions you can find on the web, but most versions include 7 steps, which are some version of what I've got here. Research and discovery, analysis and planning, design and architecture, development and implementation, testing and validation, deployment and release, and maintenance and support. Pretty simple. And not at all what actually happens. So research and discovery focuses on identifying the core value of the product and how it needs to be adapted in order to satisfy the requirements of users in local contexts. Although the requirements for internationalization are always unique, there is a common process that can be used to identify the requirements. That involves first looking at the value or the business goals of the product and evaluating whether that value is international or specific to a particular language, culture, or region. Then you need to do your market research and gather information about different markets and user segments in order to determine which of these might be receptive to that core value of your product. Collect user and market information so that you understand how the product would need to be adapted in order to appeal to users in different markets. And then analyze your product's current capabilities and determine what technologies can be used to support user preferences and business requirements. So this is basically doing your homework. And that involves doing your homework both about the markets and users that you want to target and about your own technology and systems and what they're capable of. Analysis and planning is more about taking those requirements and analyzing them in order to see if they're feasible and to estimate how much time, effort, and resources are going to be required to actually produce the software. You want to look at things like the architecture. Does the application support Unicode and other international standards like BCP 47? You want to look at the development process. How big is the development organization? Are the necessary skills and resources available to internationalize the app? You want to estimate the work. How much work will internationalization take? What does this mean in terms of duration and deadlines? And then buy-in. Does internationalization have support at the executive level? Does leadership understand what internationalization entails and why it is necessary? Design and architecture is about taking those requirements and estimates and actually specifying what needs to be built and how it needs to operate in order to produce international software. Typically involves systemic, kind of extends throughout the application, and local feature development. Includes things like locale awareness. How does the application know what the user's preferences are and how does it react to that? You got to have some kind of runtime translation system that figures out how to identify which resources you want to load, loads them, and then applies them to the user experience. You need to think about the developer experience and develop a framework for translation and localized formatting that hides the details from the developers and allows them to focus on their work. This is really important. Developers shouldn't really need to know what the locale is. They want to focus on building features and stuff like that. And so if you can build a framework that they can just use and plug into that takes care of all that internally for them, it's a great time saver and reduces things like time to market. And then finally, you need some kind of tooling and infrastructure, design systems that can manage the collection, transmission, retrieval, and integration of translations, and integrate that system with the build process. Development and implementation, pretty simple to understand. It requires system development, implementing the locale awareness and runtime translation management, right mechanisms for plugging into it, tooling development, creating tooling and infrastructure in parallel with system development in order to provide a complete solution, framework development, wrapping internationalization APIs, and programming language APIs in things specific to your application. So it removes the need to understand internationalization in order to do it. And then you have to do the actual feature development or refactoring in most cases, where you are educating and guiding development teams in how to refactor or develop their code in a way that supports internationalization. Testing and validation. There are many different types of testing that are used in software development. They include unit testing, which is ensuring that individual components function as they should. Integration testing, ensuring that the localization systems and frameworks support the required end-to-end use cases and play nicely with other systems. There's the localization testing, which you use the pseudo translation, which is just like sticking random characters on the end of a text string to expand it and make sure it can render all the different scripts. and then using additional testing on actual translations for the final experience, and then putting the complete experience in front of users and collecting feedback so you can iterate as necessary in order to achieve the best result. Deployment and release, there's the system deployment, which is the actual system that controls the internationalization. And then there's the infrastructure deployment, which is the back and forth of translation, sending and retrieving. There's language deployment. You should be able to turn localization for a particular language on and off using feature switches, and languages should not be released before they are needed. And then there's market releases, which should be carefully monitored with the ability to roll out languages and features to particular markets in an incremental way. So you roll it out to 10%, then you roll it out to 20%, then you roll out 50 and 100%. And then maintenance and support. Releasing code and language is not the end of the story. You still have to support the system and framework maintenance, keeping internationalization libraries and dependencies up to date, ensuring that you test each version thoroughly before integrating it. Infrastructure maintenance, performing regular audits of tooling and infrastructure in order to detect problems early and find opportunities for optimization. Internationalization support, supporting developers in the internationalization of their work and providing regular education support and training. And then localization support, supporting localization programmers and localizing what the developers create and serving as a bridge between developers and non-technical localization specialists. Okay, so those are the different stages in the software development lifecycle. Let's assume that we push something out, we've got it in different markets. What happens then? You have to practice something that I call continuous internationalization, which is each new feature you develop, or as you update a feature, it has to continue to support internationalization and be localized for the markets you already support. So you have to establish internationalization standards and hold developers to them. Don't let things release if they haven't been internationalized. You have to ensure internationalization is done at the right time and in the right way by defining best practices and educating developers about them. You set up internationalization processes that are easy to understand and follow. Don't make internationalization more complicated than it needs to be. And then most importantly, you need to have a program that kind of manages all this and hire a program manager to make sure internationalization continues to happen on a regular basis. Continuous localization is all about data and automation. Localization automation involves automating in a way that localization can be low touch or a no touch effort. It just kind of happens. And that will free localization program managers to focus on localization quality and strategy. You have localization analytics. Having reliable information about localization usage and impact will make it easier to decide where to invest in order to maximize return on investment. And then you have localization quality, establishing reasonable quality standards for different types of content and not wasting time over testing the quality of materials with low user engagement or impact. Internationalization expansion is when localization is extended not to a different language, but to a new aspect of the product or a new feature within that aspect. The important thing is to make it strategic, data-driven, and systematic. Strategic means there's more ROI in internationalizing features with high usage before features with low usage, but internationalization system should allow for quick expansion to additional features. Data-driven expansion means to determine which features should be internationalized, use analytics and usage data to determine where there is internationalization demand. And then systematic internationalization is having a repeatable playbook that you can use to extend localization to a new part of the product, which reduces time to market and saves money and resources. And localization expansion is the same thing, but for localization, which means you have to be strategic, determine what languages are going to have the most impact, and avoid the shotgun approach where you just localize and then hope somebody takes the bait. Data-driven expansion, target languages used in markets where data suggests there is demand, compare user preferences to delivered localization experiences. So if you have a lot of people in Indonesia who are using a particular feature, but they're using it in English, and their preferences are set to use, what is it called? I can't remember the names of the language now. Anyway, they're set to use a native language, then that is an opportunity that reveals itself to say, well, we could internationalize and localize in that particular area, and we might cause usage to go up even further. And then systemic localization, having a clear go-to-market strategy that includes cost and usage thresholds, and in business-to-business environments, use potential deal size and cost of localization estimates to justify adding new languages. Takeaways: integrate it into the process, conduct the research, be aware of the different types of internationalization and localization testing, develop scalable systems that don't require extensive maintenance but keep things up to date, and then make data-driven decisions about internationalization and localization expansion. Use metrics to determine the best opportunities and learn how to estimate internationalization and localization ROI. Unfortunately, there's not a lot of good material that focuses on the practical aspects of internationalization and how it impacts localization and globalization. And the best approach is to find a mentor and analyze successful and unsuccessful case studies. You want to learn about internationalization and localization as it happens on the ground. Success is as much about studying product development as it is about studying languages. You want to participate in forums and workshops like this one to learn about new internationalization technologies and localization processes. Don't be afraid to ask questions. At the very worst, you end up learning something different than what you intended. And then finally, get involved with Unicode and other internationalization organizations. The best way to stay aware of new developments in the field is to be there when they happen. Review. What a long, strange trip it's been. Internationalization concepts. We learned that nation is an ambiguous concept. International software is software that works internationally. Internationalization is the process of creating international software using internationalization technologies. Internationalization enables localization to scale, and it can have a positive and negative impact on translation complexity and localization quality. And then globalization is facilitated by internationalization because it makes it easier to extend localization to new features and languages. Focus areas. A locale is an identifier used to identify a set of user preferences that are common to a significant group of people. The definition of locale shows that internationalization is primarily about language, script, region, and culture. A user's localization preferences may extend to specific linguistic, cryptographic, regional, and cultural systems. Developing software in an international context makes the process more complicated, but there are recognized problems with established approaches. And understanding what the problems are and how to approach them makes internationalization more likely to be successful. Unicode internationalization technologies. Unicode Consortium develops internationalization technologies that not only make internationalization possible, but also make it faster and easier. The Unicode Internationalization's tech stack is based on the Unicode character encoding standard, but includes properties, algorithms, data, and libraries that are used in the majority of software products. Unicode technologies build on each other to create internationalization solutions that are exposed to end users through programming language APIs and platform SDKs. And understanding how Unicode technologies work makes it easier to understand how internationalization in general works, but there is still a lot of additional work that goes into producing international software beyond what Unicode does. Software development lifecycle is an idealized view. In order to be effective, internationalization needs to be integrated in every phase of the software development lifecycle. There is internationalization work to be done in every phase, and internationalization does not stop with the release of new languages for new markets. And the best way to learn about internationalization as it happens on the ground is to find a mentor and analyze internationalization case studies. Conclusions. The tutorial has tried to provide a basic understanding of what internationalization is, what it is about, how it works, and what it involves. Now that you have this basic understanding, you can dive deeper into Unicode internationalization technologies and determine how best to use them in your software development projects. Practical internationalization involves many different roles within product development and needs widespread participation and support in order to be successful. And the Unicode Technology Workshop provides an opportunity to learn from the best in the business and take your international development to the next level. Done. All right, how are we doing on times? We have 6 minutes. I'm sorry, I tried to go as fast as I could. Any questions? That was a lot. That was like the fire hose. You're drinking from the fire hose. So I'd be happy to answer any question. Yes. Let's get the mic so it goes in the recording.
Hi. So my question is, so thank you so much for the broad overview. It's very well detailed. I really appreciated that. I'm curious about, because the dynamic seems to be between, there's like the software like side of things, and then there's the language side of things. But I'm curious about, like, for example, like car manufacturers from like the second half of the 1900s, and it doesn't seem like there was much interaction because there are some characters, like for example, there's like an old like Toyota I have that, like, whenever it shows like CJK, it just becomes like asterisks. And so I'm just curious, what's the, like, a very brief like history of, like, did Unicode just not work with those car manufacturers? Did they just kind of do their own thing? I mean, now we have CarPlay and Android, and so big tech is kind of taking it over. But I'm curious if you know any of like what was happening back then, or.
I don't know a lot, but I will say the whole reason behind the Unicode standard is that before there were many different encodings, and each country had its own encoding. In Japan, you had something called SHIP-JIS. In China and Taiwan, you had Big 5 and GB 1003 or something like that. And so one of the things that the Unicode standard does is provide a single registry and a single, well, really 3, but all related ways of encoding characters so that they can be used all over. And one of the reasons UTF-8 has become so popular is because it's compatible with the kind of encodings that were there before. So when you're seeing those asterisks on the encoding, it's probably an encoding problem, right?
I mean, I think part of the issue is not everybody has adopted Unicode fully.
Yeah.
So my Toyota car from 2015 has its own internal infotainment system. And if they're not supporting characters because they're not using Unicode, then as a user, we see the problems.
Right.
But it's the people who are implementing, are they actually incorporating Unicode or not?
Yeah.
And there's a whole stack of things, right? So you have Unicode as the most basic layer, the foundation. It's how do we represent the text as characters? But then you also need to have support for fonts. You need to have support for layout rendering of those glyphs from the fonts to be in the right positions, in the right places, and and so on and so forth. So there's a whole stack that also needs to be on the same page, working together. And if that's not the case, then you see things like asterisks.
Thank you.
Sure.
Thank you. You mentioned to not make the internationalization program more complicated than it needs to be. Can you give some guiding points if, what to look for to make sure it's appropriate? Maybe some example of good program versus like overly complicated.
It's a little bit difficult. One thing is like hiding what the current locale is. When I used to design software systems, the developers had to like fetch the locale, stick it into a function in order to get the right output. But one of the things I've learned is to hide all that behind a general formatting function that just assumes gets the locale itself and integrates it before, and so the developer never even sees it. They don't need to know what the locale is. They just need to know, and they don't have to fetch it. They don't have to get it from somewhere. It's already included in the framework you've developed that you then pass over developers to allow them to create the actual features. I don't know if that's a very satisfactory answer, but we can talk later if you want. There are lots of things you can do.
Thank you. And hello, I'm wondering, like, it's the era of AI, right? How do you think AI will transform the landscape of the internationalization and the globalization?
I knew I would get an AI question. So the area where AI is going to be most significant is in natural language processing, I would say. Natural language processing is a completely different approach to dealing with languages, but it can be used within internationalization to perform some very specific functions like transcription or text-to-speech or language detection, for example. Those are all functions that have been around for a while, and things like large language models just make that more natural. Because before you used to have a very like one-to-one kind of relationship between terms and mathematical probabilities. And what you have with LLMs is you're predicting what the next term is going to be as you're going through and generating or understanding language as it comes in. So I guess the short answer would be that I don't think it's going to massively transform internationalization. Localization, on the other hand, may see some real transformations because it can do a lot of the translation things that are currently being done by expert linguists. So, okay, I think we're done. Thank you guys so much. You made it through.